Hello, welcome everyone to the next video in the series of GATE and CSI UGC NET questions. So let's look at the question of today. So the question appeared in GATE 2020. So let's read the statement first. It says if D1 and D2 denote the dual problems of linear programming problems P1 and P2 respectively, where P1 is this and P2 is this. So we are given two LPPs, their statements, complete structures are given to us, and D1 and D2 are their respectively duals. Then, so we have to choose the correct option. Both D1, D2 are infeasible, P2 is infeasible and D2 is feasible, D1 is infeasible and D2 is feasible but unbounded, P1 is feasible but unbounded, and D1 is feasible. So let's see what is the right option and how to make strategy to solve this kind of question. So the first thing we need to understand is, because usually these are coming as multiple objective type questions in GATE or NET exam, so we do not necessarily write the duals first, so we have to first use some results. If we can find some answers using the weak duality or the strong duality theorem, then we will be able to solve the question. So let's look at P1 first. So since both of these problems are two variable problems, and we very well know that the two variable problems can be solved graphically, so there is no need to apply simplex method. So very quickly we can draw the feasible region for P1, and let's see what is the structure of P1. So for that, let's move ahead. So I'll be drawing the feasible region of problem P1. So there is just one constraint, minus x1 plus x2 is equal to 10, which is a straight line. Obviously this will be passing through these 2 points, minus 10 comma 0 and 0 comma 10. So what I'm going to do is just draw this line here. So this is minus x1 plus x2 is equal to 10, and since these are non-negative, so that means this is our feasible region. This whole straight line lying in the first quadrant, so we have an unbounded feasible region. And what is the optimal solution of this LPP? Since this is a minimization problem and we need to minimize this one, so you will be able to find out that this x1 minus 2x2 can be minimized along this line. So there is actually no optimal solution exist, because you can see the coordinates of this point are 0 comma 10. So at 0 comma 10 the value of this objective function is minus 20, while if you take any other point on this line, say if you take the point say you take minus 10 and 20, say 10 comma 20, so in that case the value of objective function is going to be 10 minus 2 times 20, so that is 10 minus 40, which is minus 30, which is even less than minus 20. So that means along this line what is happening, z is continuously decreasing, and being a minimization problem, so that means we cannot find the minimum value of z. So this LPP P1 is basically unbounded. And there is immediately result about the corollary of weak duality theorem, which says that if one of primal or dual is unbounded, then it implies the other is infeasible. So if primal is unbounded, so that means its dual D1 is infeasible. So this clearly gives us the hint that either the correct answer is A part or the correct answer is C part, because this both is mentioning about D1 is infeasible. In D part it is saying D1 is feasible, so this is clearly not correct. So we have eliminated one of the option, and remaining options, out of the remaining options we have to choose. So about D1 we have decided, now we have to decide about D2. So to decide about D2, you look at P2. So if I draw the feasible region of P2, so I have given two constraints here, and as you can see both of these are parallel to each other, both of these straight lines, because they are just scalar multiple of each other. So if you draw just one line, it will be easy to see. So the first line is the same one, minus x1 plus x2 is 10, and the second line all of you can identify will be lying here. This is x1 minus x2 is 10. So the coordinates will be, these are 10 comma 0, 0 comma minus 10, this is minus 10 comma 0, this is 0 comma 10. So these both are parallel lines, and clearly the constraints are equality constraints. So that means we should be able to find a point which is simultaneously satisfying both of them, which is not happening because there is no point where they are going to meet as they are parallel. So this clearly shows that P2 is infeasible. There is no feasible solution of it, right? So if P2 is infeasible, it implies its D2, its dual is either unbounded or infeasible. This result is also coming from weak duality theorem. Okay, so for P1 was unbounded, we could definitely say it is infeasible, but when one of the primal or the dual happens to be infeasible, then the other one can be either unbounded or infeasible. So that means we are not sure about D2 yet, so that's why we have to find D2 and solve that. So writing the dual of P2, so it is going to be maximize W is equal to 10y1 plus 10y2. I hope all of you are clear about how to write the dual. So I'm just assuming that and writing that directly. Minus y1 plus y2 less than equals to 1, y1 minus y2 less than equals to minus 2, and both y1 y2 are unrestricted. So in this dual, if you try to solve this, because this is also having two variables, so you can solve this graphically. So these will be also two straight lines. This is the first line, minus y1 plus y2 is equal to 1. So this point is minus 1 comma 0, this is 0 comma 1, and another line is, you can see, is just the parallel of it having the same slope. So this is minus y1, sorry, y1 minus y2 equals to minus 2. And now you look at these signs. The first constraint sign is less than equals to. So the region will be, it's satisfying 0 plus 0 less than 1. So the region will be downwards because it should include 0 comma 0. While for the second constraint, 0 comma 0 does not satisfy this because 0 minus 0 is not less than equals to minus 2. So that means it should be that region which does not include 0 comma 0. So since you can see there is no intersection between these two regions, so D2 is also infeasible. So we got our correct answer is A part, both D1 and D2 are infeasible. So that's all about this question. Thank you for watching.